Dear aspirants, welcome back to our channel. Let's discuss the next topic, that is deuterations in proton NMR. In the last video, we have seen the effect of proton exchange in the NMR. If you have the impurity in the sample, the heteroatom protons will not be recognized. That's why there is no coupling. That will be considered as a singlet. Right? If you have deuteration phenomena, what happens in the NMR signal? Okay, so what is the deuteration? The mutual exchange of proton and deuterium on heteroatoms. Otherwise, replacement of heteroatom proton with the deuterium by heavy water is commonly called as deuterium exchange or deuterations. This is also possible in similar kind of molecules, alcohols, acids, amines and thiols. See what we are doing? This proton is the heteroatom attached proton. We are going to replace this proton with deuterium by reacting the moiety with what? Heavy water. Thereby, the hydrogen is replaced with deuterium. This phenomena is commonly called as deuterium exchange, deuteriation. Okay. So, how the deuteriation is useful in NMR studies? Okay. For example, let us take this molecule. Assume that this is impure in nature. What is the meaning of impure? Proton exchanges are possible. Large number of proton exchanges are possible in the molecule. That's why what happens? The OH will not recognize CH3. CH3 will not recognize OH. So it will become appeared as a singlet. It will become appeared as a singlet. So it will give one peak here. It will give another peak here. Then what is the use? What is the use? Suppose if you do the deuteration, what happens? The H is replaced with what? D or not? So it will become an CH3OD. Then take the spectra of this molecule. How many signals you can get? Only one signal or not? That signal related to CH3. The OH signal is going to be what? Disappeared. OH signal is going to be disappeared. Then what is the use? The use is, with the deuterations possible to predict the heteroatom protons in the sample. Suppose, assume that you have one unknown compound. In that unknown compound, you want to check whether the heteroatom proton is present or not. It means whether OH group, NH group, COOH group is present in your unknown compound or not. If you want to identify, then we need to go for deuteration. What should we do? Simply what happens? Initially, we will take the proton NMR spectra of the unknown compound. So, keep it with you. Then what you need to do? Add some heavy water to that one. Okay, to the unknown sample, add the heavy water and do the deuteration phenomena. Then take the spectra. Okay, then what happens? If OH, NH or COOH, any group is present, what happens? That proton is replaced with D or not? That's why in the unknown sample, you have the spectra, right? By adding the heavy water, you have the spectra. If the disappearance of any one signal in the spectra confirms that your unknown sample is containing some heteroatom proton. That is the useful of deuteration. See this one. First record the general NMR spectrum. Okay, you have the spectra. Then we add D2O. This peak is missing. It means that what? The unknown sample is containing heteroatom protons. It means unknown sample may contain OH group, NH2 group or COOH group. Okay, this is the usefulness of deuteration. Okay, in the next video, we will be discussing dynamic proton NMR. So what is the significance of dynamic proton NMR?